So section 8.5, let's start with the complex plane. Complex plane. So you already know the complex number. For example, z equal a plus bi. This is the real part, and this one the imaginary part. So we're always gonna say with the complex number, we're gonna say z equal a plus bi, the real part, and there's the imaginary part. That means when you try to graph it as a point, because the complex number is going to be like a point, you're gonna say AB, or we're gonna say this is X, Y. But there is difference. You say, okay, how are we gonna graph it? Because we're gonna graph it on the complex plane, which is different than XY plane. Complex plane. Okay, how does it look like the complex plane? The horizontal axis is called the real axis. So here's the complex plane. This is the real axis. You're not gonna say X coordinate anymore or X axis. This is the real axis, okay? The vertical axis is called imaginary axis. So this one is the imaginary axis. So any point, this is the real axis, and here is the imaginary axis. When you graph it, it's look like X, Y. But this one is going to be the real axis, and this is the imaginary axis when you want to locate the point Z. Okay? The next part, we're going to do examples about this one. The absolute value of any complex number, Z equal A plus BI, this is the complex number. The absolute value for the complex number is going to be the real part squared plus the imaginary part squared and under the square root. What does that mean? That means the absolute value of complex number defined as the distance between the origin point, which is the point 0, 0, and the point AB. Because here is the complex number, that means you're going to get the point AB. The absolute value, it means the distance between the origin point 0, 0 and the point AB. Okay, that means the absolute value for the complex number. The trig form for a complex number, and that's what we're going to use to the next section. Any complex number, Z equal A plus BI, you can write down as Z equal R cosine theta plus I sine theta. So any complex number, you can write it down as a R cosine theta plus I sine theta. This is called polar coordinate. When you're taking Cal 3 or Cal 2, you will hear polar coordinate, which means a complex number. So that's the form A plus BI is the same thing, R cosine theta plus I sine theta. Okay, polar coordinate. How are we going to find the A? By R cosine theta. How are we going to find B? By R sine theta. You're going to plug in A and B here, you're going to get the complex number. How are we going to find the R, which is the distance between the point, the origin point, and the point AB? By A squared plus B squared. So that's how we're going to find a complex number if it's polar coordinates. The sum of two complex number or difference between two complex number, you're going to add, here's two complex number, you're going to add the real parts, and you're going to add the imaginary parts. So don't confuse yourself, because sometimes they're going to switch the real parts and the imaginary parts. Just go ahead and write the complex number again, add A plus C, which is the real part, and B plus D, which is the imaginary part. Okay, it's not that much hard, this section. Let's try to do examples. We're going to plot this complex number, and at the same time, we're going to find the absolute value for each complex number. So to plot this complex number, that means this is 3 and 5. I'm just going to graph 3 and 5. This is A and this is B. That's mean to graph it. Just look like because here is the real axis and here is the imaginary axis. So it's look like X and Y. That means 1, 2, 3. And Y is going to be 1, 2, 3, 4, 5. What is our complex number? Z equal 3 plus 5I. But you're not going to say XY plane. You're going to say, no, the complex plane, this is the real axis, and here is the imaginary axis. The absolute value for this complex number is going to be the distance from the origin point 0, 0 to this point, Z equals 3 plus 5I. So this is the absolute value of Z. How are we going to find the absolute value of Z? The absolute value of Z, which is the absolute value of the complex number, 3 plus 5I. You can say, okay, it's the square root of the first number square plus the second number square. So it's going to be square root of 9 plus 25. It's the square root of what? That's it. That means the square root of 34 is what? Is the distance between 0, 0 and the point AB, which is the Z. This is the point 3 and 5. Is that hard? That means the complex number here is the real part, and here is the imaginary part. To graph this one, then we say, okay, it's -2. Here's -2. And here's 6. 1, 2, 3, 4, 5, 6. So here is our complex number. -2. Here's the distance, which is the absolute value of this complex number. So I'm going to say the absolute value of Z is the absolute value of the complex number, -2 plus 6I, which is equal the square root of. Here's is going to be the mistakes. So be careful. When you're saying -2, put parentheses, -2 squared. Because if you say -2 squared, and you plug in this one in the calculator, is going to be what? -4, which is wrong. Because the squared for the negative sign and for the number. So that means -2 squared, which is equal 4. You see the difference? That means -2 squared plus 6 squared. So it's going to be square root of 4 plus 36. It's going to be the square root of 40. Do we have square root of 40? Yes or no? It will say 4 times 10. So that's mean 2 square root of. Yeah. That's it for this one. What about the third one? For example, can we do the same thing? So the complex number, here is the real part, and the imaginary part is -3. Let's need to graph it. -1 and -3 is 1, 2, 3. Here's our complex number, which is -1 and -3. To find the absolute value of Z is going to be the absolute value of -1 minus 3I, which is equal square root of -1 squared plus -3 squared. So square root of is going to be 1 plus 3 is going to be square root of 4, and it's going to be 2. That's it. What about number 4? How much the real part? How much the real part? Do you see the real part? So how much? 0. So if you're missing the real part, this one is exactly the same thing. It's z equals 0 plus 3i. So I'm missing the real part, which is 0. So 0 and 3. So here's our complex number. This is the real part 0 and the imaginary part 3. So to graph this one, 0 and 3. So 1, 2, 3. So here is our complex number 0 and 3. The same thing if you want to find the absolute value, which is the distance between the 0 and the number. What do you think? How much is going to be? Let's see. Going to be the square root of 0 square plus 3 square. So there is square root of 9, which is equal to 3. And you can tell the distance between 0 and the number is 3. 1, 2, 3. So we get the distance is the 3. Good. The square root of, no, the negative 3 squared is going to be 9. So it's going to be 10. And that's it. Leave it like this. The main thing when you need to find the sum and difference, you have to be careful with the sign. So let's check here. How are we going to find the sum between these two complex numbers? You're going to add the real parts and you're going to add the imaginary part. That means it's going to be 3 plus 6. And here is going to be 4 plus 3, and here is the I. So it's going to be 9 plus 7i. Is that R? What about the next one? Now we have minus between two complex numbers. We need to find the difference. So be careful. It's like you're going to distribute this sign. So you're going to say it's 7 minus 6. And what are you going to put here? Let's do it easier. It's look like when you're doing the difference, distribute this sign. So this one is 7 minus 3i. I'm going to say minus 6 minus 4i. Okay, so you're not going to do mistakes because you're going to say, okay, when I'm going to put sign between the numbers. Now 7 minus 6 is going to be 1. Negative 3 minus 4. Negative 3 minus 4. And here is the I. You got it? So I prefer that you look like distributing the sign and then combine the like terms, or combine the real parts and the imaginary parts. It's going to be easier, you're not going to do mistakes. 7 minus 6 is going to be 1. Negative 3 minus 4, because here's an I. So it's going to be negative 7. We're going to do the same thing with the next example. But check, do we have missing a part here? 0. So if you want to say, okay, it's the same thing, 2 plus I minus, I'm going to write down 0 minus 3i. So I'm not going to do mistakes. Or you're going to say, okay, the 0 is not going to change anything. Here is the first number. Negative times negative is going to be positive, 3i. Do you have another real part? No, so 2 is going to be still by itself. I plus 3i, how much is going to be? 4i. 4i. Because here's a coefficient. 1, so 1 plus 3 is going to be 4i. That's it. Another example. So here's the first number is negative 3 minus 4i. We're going to say negative times negative is positive 1 plus 1 negative. And positive is going to be minus 5i. So negative 3 plus 1 is going to be negative 2. Negative 4 minus 5 this one on 1414. The distance formula between 2 points. X2 plus x1 squared, y2 minus y1 squared. It's the same thing. So if they ask you find the distance, let's do an example. To be careful, here is the midpoint formula. The distance formula is exactly when you find the distance between 2 points in XY plane. Here's the midpoint formula. And to find the midpoint, it's going to say A plus C, which is -8 plus -5, divided by 2. And B plus D, that's been 1 plus 8, divided by 2. Here's going to be the midpoint. I think we have 2 examples. One to find the distance between 2 points, and one to find the midpoint.